Today we'll be covering question 1 of the written exam for the VCAR exam. So let's start by deriving the function here. So here we have y equal function ex cos 3x. Now, as we know, this follows the composite rule, and we want to break it down structure by structure. So let's start by following the product rule. So we have a function which is y equal to ex, which we'll use as one function, and another one which is another function. We'll call that y equal to cos 3x. Now, when we're multiplying here, what we want to do is, to make it easier, we'll call this fx and we'll call this gx. So we'll call this fx as this function here, or we could call it fy, but it's better to write as fx through this notation, because this is what basically is substituted. So we'll call this gx, and now we know our function for our fx. So we have fx equal to ex. We know that the power of ex brings it like a normal derivative. So this will just be ex as our derivative. And our next function, which is gx, we know when we derive a cos function, we bring out the power in front. So we have cos, and it turns into negative. So -3 sine 3x. Now, if we want to derive this as our dy dx, we multiply our fx function by the derived function, and the derivative of the f of x to the g of x. So if we do this, this will give you dy over dx equal to e to the power of, this would be multiply -3ex sine 3x plus ex cos 3x. And the reason why we add it is because of the derivative rule, and this gives us our derivative. So this is a 1-mark question. So you show you're working out here. It's a bit messy, but you would show you're working out here. Now, let's think about the log of function. So we have fx equal to log e x to the power of 3 minus 3x plus 2. Now, to derive this function, we need to let this function inside be u. So we have u equal to x to the power of 3 minus 3x plus 2. Now we want to write f of x in terms of log, in terms of u. So this turns into fu equal to log eu, as you can see here. So then when we actually derive this function here, we can write this function. So we can derive this. So du equal to x3 minus 3x plus 2, and we derive it. So du dx, we bring out the power when we derive. So 3x and minus the power by 1, so x squared minus 3, and the constant stays the same. The constant is gone when it's derived. So now we have du dx, but we want it in terms of dy dx, right? Yeah. So if we bring this function here, so we have dy over dx here, we can multiply them. And basically what happens is the dy in terms of the du, which we wrote here. So we now have the du dx function, right? Which is this value here. We can substitute. So we have 3x squared minus 3 times by dy du. So we have y equal to 1 over u when we derive it. Because when we derive a logarithm, it just becomes into a reciprocal, as you can see through here. Now, all we need to do is we need to substitute our value of u in. So therefore, using this logic, we have dy over dx equal to 1 over x to the power 3 minus 3x plus 2 times by 3x squared minus 3. So therefore, by default, our function is 3x squared minus 3 over x to the power of 3 minus 3x plus 2. And that will be our divide function. So the first mark, but it's not over because we need to substitute f to the power of 3. we substitute it in as well. This will give us substitution. So 3 times 9. 3 times 9 minus 2. And this will be divided by, this entire thing will be divided by x to the power 3, sub 3 in. So this will be 27 minus 27 again. And this will be, so let me check over this. So dy du, 1 over x to the power 3 minus 3x squared plus 2. So no, plus 2 here. So I forgot the plus 2. So be careful when you're substituting. Plus 2. So you have 27, 25 over 2, which gives you 25. So therefore that value is 25 over 2, and that will give you your divide function for f to the power of 3 as shown here. And that's how you solve for question 1 of the 2024 exam 1 question as well. Hopefully that makes sense.